Welcome everyone, my name is Jeff O'Brien, and today with me my special guest is Chief Jackie Gibbs. We're going to be talking today a little bit about the features and the really cool parts of the glance preemption system. Take you through some videos, show you some preempt speed profile reports, and really talk through why and how the glance preemption system is really the best preemption system on the planet, and some really cool reasons why. So, Chief, we'll probably just start off talking about what is glance preemption system? What is that to you?
Well, to me, it's one of the most important safety features available to public safety broadly. In the years past, you know, we've had all sorts of equipment to help us complete our mission of responding to emergencies. And glance is that thing that has come along that is making, in my mind, the most dramatic difference in the ability of emergency services to deliver those services safely and quickly. So for me, I think it's a huge change in the way public safety can respond to emergencies.
You could talk a little bit about how long you've been in the fire service.
Well, I did 41 years in Marietta, Georgia in the fire department. 18 of those years I was fire chief. And so I spent my entire career in Marietta Fire.
You talk a little bit about how technology and maybe how training has changed, the intelligence about who to hire and how to hire and where to put fire stations, and what's that all about? Obviously it's focused on improving response time and helping the citizens of the community, but can you talk a little bit about how that's changed over the years?
It really has changed. We still worry about geography. We still worry about the developed area that you're responding to with the fire department specifically. So you're trying to locate your fire stations strategically to the developed or the built upon property of a city or a county. And so the reason you're doing that obviously is those response times. You need those particular pieces of equipment and staff available to get on the scene in a timely fashion. And that is the thing about responding to an emergency situation where it's someone's worst day, is time is exponential. Fire growth is exponential. In today's world, responding to medical emergencies, things are going quickly wrong. And so time is of the essence. And then the safety aspects of it is getting there safely. You're of no value if you don't get there. And so we have to get there in a timely fashion. Traffic, of course, is completely different than it was. You know, as cities grow, and we've learned that the public really likes their cities to look nice, and they like traffic to move in certain ways. And so streetscapes have become really important to cities and counties, and as far as having nice looking boulevards and roads. Well, those can become traps for emergency services, and so those things impact the way we deliver services. And staffing is always an issue. You know, having enough people on the scene to get the job done, always critical.
Yeah, one of the questions that I had, I think you probably answered as a part of the response, was if we lined up 100 different fire chiefs from different departments from around the world and asked them that question, what's the biggest challenge that you have today in emergency response?
It's traffic. I mean, it is traffic, and we have competing interests a lot of times, because for the public, they want traffic to go slow. And in emergency services, we need traffic to move so that we can get through in a timely fashion. And so you have those competitive type things. As cities and counties develop, they become more dense. Zoning has changed a lot. Buildings are built in higher capacity, narrower, closer together. So we're putting more people on less footprint, which raises your fire problem, raises your emergency services challenges. So it's really all of those things at once. And so that's what makes glance really good, because you're using technology to offset those challenges. And technology today is moving fast, developing fast, and really has become very competitively priced.
So entertainment districts, bringing in industrial business, bringing in headquarters businesses, bedroom communities, all of those things are financial engines to these agencies. it means people, it means revenue. It also helps to fund a lot of the projects from around town, but it also brings with it the idea
the need for service.
It's congestion,
It is.
and so it's the need for improvements in services as well.
Right, and you get those competitions going. City fathers, city leaders, they want that development because, as you say, that's what drives the economy, is the business development, and so goes the service need as well.
Yeah, let's transition into one of the diagrams that we have. You've no doubt seen the 1, 2, 3 slide that we have on the screen here. Can you talk a little bit about how the 1, 2, 3 sort of works together and how it starts to build the acquisition of data and the acquisition of information? So the fire trucks, as they're going, this will just showing just one intersection, but it's likely talking to dozens of intersections simultaneously. Can you talk a little bit about the 1, 2, 3 and how it builds its value in its response?
That is, in my mind, what really makes Glance stand heads above other types of systems, is because you're using redundant communication. And for the fire service, we're always looking for redundancy. We want to make sure that if one thing fails, another takes over. So with the slide you're seeing on the screen, you have the shortwave radio that is going to the traffic cabinet. You also have the cellular signal that's coming out of the top of the fire truck, going to the cell signal, going to the cloud, and then back to the traffic cabinet. And these systems are working in sequence right together all the time, and so they're looking for the fastest connection, the first one to get there. It also, in downtown areas where you have bridges, trees, and that sort of thing, you don't have interference because you're using that cell signal to get past that. Glance also reaches out to all of the signals around where you are, so that those traffic signals are actually looking for you, and they're saying, are you coming my way? And so we connect that system to the turn signals on the vehicle, so that a driver operator is actually managing their response. They're managing the pathway that they need to go, which to me makes Glance really beneficial, because you're putting the apparatus operator, in the fire department's case, you're putting that operator in charge of their own path. And so they get to help use the traffic system to clear that path. And that's, to me, you can't ask for anything better than that, is to be in control and to have control over the path you need to go on. And you're using that redundant technology of shortwave radio with a GPS system and then cellular, so that all of those things work together. As it also goes, as you're going through the system, it's collecting data. And it's given the fire department administrators lots of information about how the system is working and how you're responding through it. So they always can see that situational awareness that an administrator wants to know, that, okay, what I'm doing works, and what I'm doing is effectively delivering service to the public.
Nice. As we look at the 1, 2, 3, it seems like there's some simple steps there. There's really a lot going on all 3 of these elements. Where you talked about earlier, we've got the number 1, that's the cellular side. So it's reporting second by second to Glance that they're requesting preemption and sharing some heading information. That's being rebroadcast, typically over cellular, back to the intersection device. It's also receiving that direct communication you talked about, the redundant 900 megahertz that goes right into that cabinet. It's the same message set. So like you said, no matter what happens, last year we had a couple of outages around the country where AT&T took a great big dump. For hours at a time, they were offline. So those agencies that had our system had 2 ways of communicating that request for preemption. So they were still getting their green light requests into the intersections and doing what they needed to do. So super cool way of looking at how we're looking at the redundant communication as a part of this tool.
Right, you're never reliant on one. You've always got that backup system, and for delivering emergency services, you always want to know you're prepared. You're in a situation where you can get your job done, you can get the mission accomplished.
Well, you and I have spoken before about some of the standards and the policies in fire training, fire protection, NFPA. Can you talk a little about maybe about how the 2 channels of communication that we have is a redundant tool, much like the principles and the policies and standards of NFPA?
Sure. With NFPA, again, with the fire service, that is sort of who we look to nationally to give us standards, to give us guidance and best practices that are developed worldwide, really. And that comes back to the fire service. And over the years, capitalizing on all that, you have 2 in and 2 out. So you got firefighters, you got 2 firefighters inside taking care of business in the fire, and you got 2 outside as a redundant system, as a backup. And then you always have a backup line. So if you're advancing a fire on a fire, taking a line inside of a building, you've always got a backup line there. So again, Glance is just capitalizing on what the fire service knows best, and that is having 2 things: having that backup, having that redundancy. And so Glance plays into lots of the national standards on service delivery because, again, we're an emergency services function. Our mission is to get there safely, but get there quickly so that we can accomplish our goal.
So, and then kind of going back to the 1, 2, 3, so the request has gone out on the dual communications 900 and cellular, and the number 3 hadn't talked a ton about that, but that's also an element that a lot of the details that happens at the intersection are then chronicled and shared with Glance. So it gives us the ability to go back and do some playbacks, some heavy duty research into what happened. Oftentimes when we talk with the fire service folks, people who are driving, things happen. There's electronic devices out there, and they see things that happen that maybe they were not ready for or weren't expecting along the route. So oftentimes they'll say, hey, Chief, we were driving today and we were going and it didn't quite work right. Can we take a look at it? Can you talk a little bit about how this tool helps to provide some feedback both to fire and traffic?
Right. You get quality assurance with the Glance platform. You get data, everything you want to know about that response. You get speed, you get direction of traffic, you took the path, which way you went. You get everything you want to know about when Glance communicated with that signal, how the approach was, how the approach came about, when the light turned green. Everything you need to know to look back at a system to say, okay, what's my situational awareness? How did things work? You've got quality assurance built into every piece of it. You can look at it, then you can use that information to make something better. And that's what Glance is, really adaptable and adjustable, so that if, for whatever the traffic reason is, the greens aren't quite as fast as you want them to, that can be adjusted. We know as traffic patterns change in the daytime, you'll have rush hours where traffic completely stacks up in an area. And that's one of the beauties of Glance is, as you get to those signals, you will know when those systems are working, and the Glance will keep track of you and will monitor your progress. If you're not making progress, Glance can advance itself to other signals to start to flush that traffic out of the way. To me, this really provides the traffic manager side of the house with a great opportunity to take the chaos out of emergency response. You're having a situation where you're trying, as a traffic engineer, you want to move traffic. And that's the public's expectation of you as the traffic engineer. But you have this competing interest of an emergency that comes up that affects the community. It affects some person, some individual, very, very personally. They're having a crisis. They could be in a life or death situation. And you have to get that piece of emergency equipment through the traffic. So if you can control that and you can open that corridor, get that emergency vehicle off the system, let the traffic system return to its normal operation quickly and effectively, to me, you've done the best you can do, because that emergency happens. And if you don't have a system like Glance, then you're throwing the public to a situation where it's chaotic. They don't know what to do. There's nowhere in cases for them to go. And so Glance gives the traffic engineer an opportunity to move that emergency vehicle safely through, let them complete their mission, but then you complete your mission because you've controlled an emergency situation and nobody's had an accident. And that's a big deal if you're the person that winds up getting in an accident because an emergency vehicle came through.
Yeah, so we've talked about how the a system like Glance delivers, oftentimes as sort of a counterbalance, here's what it's like in a lot of agencies. I want to play for you a video that that demonstrates a little bit of what the average emergency response driver experiences generally on most runs at intersections that aren't equipped. I'll likely try to stop through some of the videos and maybe ask your thoughts. With your tenure, you've had an opportunity to be the lowest guy on the totem pole at the fire service, driver, added experience, and ultimately the chief of the Marietta Fire Department. So I might ask on both sides of the fence, hey, how does that make you feel? What's your response on that emotionally on as a driver, as somebody who's in the front of the fire truck, and then maybe ask you to kind of relate some of your thoughts about that as chief. So let me get this going here. So this is pretty typical of somebody just leaving out of a fire station. Seems pretty normal so far, right?
So far, so good.
Nice and clear. So here we are. You can barely see in the distance signalized intersection. You got a queue of traffic. They're all sort of stacking up. What's on the mind of an emergency vehicle driver at this point?
And you know, this is a perfect example, because as an apparatus operator is trained, as they come through their training, you know, beginning as a relief driver, a recruit, and then they advance through the testing system, because it's a promotion. You know, many people call them a sergeant. You're trained all the way through. We're asking this person to deliver emergency services. They know, based on their call, this may be a life or death situation. This could be a fire that they're going to. They need to get there quickly. And we've asked them, everything about the fire service is fast. But we also tell them their responsibility is immense, because you're responsible for not only the lives of the members of your crew, you're responsible for the lives and the safety of all of those people stacked in front of you in those vehicles. And we know that new cars like this are very soundproof, and so the people in that intersection in the distance have no idea that fire truck's there. I don't care how loud the air horns are, I don't care how loud the siren is, they can't hear it. And these people are caught in that streetscape cattle trap that you see there, with a curb line on both sides. The lanes are stacked. There's nowhere for them to go. So you, as the apparatus operator, have to try to find a pathway to start moving those vehicles, watching what they're doing, one at a time, hearing in the radio this constant traffic, that where this incident that you're going to may be advancing completely out of control. You just don't know. The pressure on the apparatus operator is to get through that traffic safely, but get through there you must. And so you're asking these people to jump up on curbs, to get out of their lane of travel, to miss their green light, which interestingly enough, some people really get irritated to miss their green light. And so you're trying to push these people out of the way using air horns and sirens. Many times they completely flip out. They don't know what to do. They just stop and they just sit there. And then you have to sit there with them until you can get one of them to come back to earth and say, okay, I need to get out of the way.
Let's play through and see how much longer it takes for this vehicle to push his way through.
You see, he's just trying to make a path. And this person really doesn't know which way to go. They're at least trying to get to the right. The others on the left are just stopped. The ones on the right have nowhere to go. And he's just trying to, now here you got one going left. So the apparatus operator is just trying to pick a hole. to get through, and they're not even close to the intersection yet.
Yeah, oftentimes when I chat with folks, a little tongue-in-cheek, I say this is the human game of Frogger, and it's sad, but it's true, right?
It's a great description, actually.
Just trying to get through this sea of people that have been trained, presumably, what to do when they hear and see a fire truck. But again, as you talked about, there's curbs on both sides and a red light ahead. Where do I go?
Where do you go? Where do you go? And as an apparatus operator, one of the things you fear is pushing the people at the front of the line into that intersection by running the red light and getting in an accident because other folks have a green light on the opposing approaches. Yeah. They have no idea why this person has suddenly pulled into the intersection. So as an operator and as a company officer who's responsible for the rig, you don't want to do too much with air horns and sirens because you're afraid of pushing somebody that panics and jumps into that intersection and gets hit.
I'll play this forward a little bit more. They're starting to clear a channel for this emergency responder.
See, this person has no idea what to do. And here they go out into the intersection.
So how often would you say that this is a normal intersection interaction on an average emergency response without a preemption system?
Every day, every time. I mean, that happens countless times in developed areas where you have a reasonable amount of population. That happens over and over again. And you can see the risk. You can see the risk in front of you that opposing traffic is coming. They don't hear you and somebody pulls into that intersection trying to get out of the way and gets themselves in an accident. The other thing you have is those opposing approaches, the first car coming may suddenly hear the fire truck. Maybe they're driving with the windows down or whatever, and they stop suddenly, but they've stopped on a green light. The person behind them isn't typically looking at the tail lights in the car in front of them. They're looking up at the traffic signal. They're looking up at a green light. They have no idea in their vision that the car in front of them has stopped. And so the rear end collisions are very common in this kind of this type of situation where you don't have a preemption system. This is one of the things to me that's the most important about glance and about preemption systems is it provides control and it takes the chaos out of that system, and you are not only creating a safe path for the emergency responder, you're bringing those other approaches safely to a stop, and you're not causing accidents as you try to get to where you need to be in an emergency.
What's a common response? This engine was in response. If there was an incident where someone got hit either to a minor or a major degree, there was an accident as a result of those people moving, how frequently would that engine company stop to help those people versus continuing to the original call that they were assigned to?
Typically, they would go on the call they were assigned to and call in an additional resources and tell them there had been an accident there and to dispatch additional resources to that accident, unless of course they're involved, and then they would stop, which happens far too many times that they're actually involved in the accident that happens in those uncontrolled situations. It's to me, it's just not acceptable anymore to create that kind of risk, knowing that there's technology here that will allow you to deliver your services, deliver them safely.
Now, as chief in Marietta, you were a part of a study that looked at the average number of intersections that an emergency responder would go through and had some insightful data. Can you share some of that information?
Well, and we looked at, much like you just saw in this video, the number of seconds that fire apparatus lost trying to get through that congested intersection. We saw that we would typically run about 6 intersections on an emergency call because we were a downtown area and it was fairly congested. And it was easily discernible that as we just measured those, that we were losing 10 seconds per intersection if we didn't have the preemption system. Once we got that preemption system, we were looking at, we were saving a minute every time, because we typically go through those 6 intersections, picking up those 6 seconds. Even if the intersection is clear, even if you have, you just have a red light in an uncontrolled situation, we required our apparatus operators to stop because it was red, gain control of that intersection, be sure they had control of that intersection, and then proceed with caution. That's 6 seconds you've lost right there, or usually as many as 10. And so going through that, just getting those green lights in there, we knew that we were picking up those 10 seconds per intersection simply with that. Even if it was, unlike this video, where he had stacks of traffic to try to push through. I have seen, just since I've retired and come over to the traffic side of the world, as driving myself, I've routinely seen fire apparatus lose 1 minute at one intersection, trying to get through a big intersection that was congested and crowded. Well, if you go through 6 intersections and you lose a minute per intersection, you've added 6 minutes to your response time before you ever even start your work.
So it dawns on me there's some direct and indirect elements on the emergency response. One of the things I'm thinking about as a young driver, you've got 20-ton fire truck, you got your personnel on board, you're responsible for getting those guys to the scene. So there's whether people recognize it or not, there's a stress level at managing those issues. So I would imagine if you're able to share some green lights along the route, it impacts the stress levels, and maybe not even just to the personnel, but the stress to brakes and drivetrain. Do you have any experience where that's had some either anecdotal or some real information from the mechanics guys?
Absolutely. These trucks are heavy. They are, when they're responding, that having to bring them to a stop in a large intersection like that with a lot of traffic, it's a routine thing. You're getting the brakes hot when you have to stop suddenly, and as those occurrences happen, you can actually bleed yourself out of brakes if they get too hot. So, you're going to see such an improvement, and we see it in the data. We talked a little bit about the data. You can actually see in the data, you can see the improvement in the response. You can see the fact that there's not any hard braking. You can see the fire department's response curve as they move smoothly through the traffic. Every one of those hard braking incidents had taken evasive action, those sorts of things. Huge safety factor, but huge wear and tear factor on the fire truck. The drivers are also really pressed, trying to get through that. I call it chaos in the cab, and that is very real. I recently was talking with a deputy chief of a department near here who'd been in an accident, and the chief was interviewing his personnel, talking with them about what happened in the accident, as you would normally do in a review when there's an accident by the safety committee. And the apparatus operator was like, I was coming up on the intersection. They did not have glance. They didn't have a preemption system. The light was red. I stopped. The captain was on this side of me saying, clear, clear, clear. I was looking both directions, but he didn't see the car coming. There was a car coming through there. Everyone else had stopped, but this one automobile saw an empty lane, didn't know why everybody was stopping, and T-boned the fire truck as they got into the intersection. So there is a lot of chaos that comes out because glance takes all that off the table. The captain is just looking. They won't have to say clear, clear, clear because the apparatus operator has a green light.
Chief, we were talking about the chaos at the intersection, and it dawned on me, again, kind of going back to the redundant communication with 900 and predominantly the cellular. We have super long ranges. It's, when you think about cellular, I can talk to people around the world on my cell phone, and similarly in the system, utilizing the cellular, we have an immense amount of capability for range, to talk into these intersections so that by the time that fire truck gets there, what we saw in the video, that's already gone, right? So
that is one of the major factors with Glance, is that you do have that range and you do have that adaptive system that will monitor your speed, and it sees you and it sees really what's happening along the response profile. So you have these long ranges, you have these long boulevards where traffic stacks up at certain times of the day. Glance can actually reach those signals, and it knows that you're coming, and it starts to flush that traffic out of the way. It also, in downtown areas around buildings where you would get interference with radio and that sort of thing, the cellular signal going to the cloud, coming back to the traffic cabinet, gives you that clearance, flushes that traffic out of your way regardless of objects in your way, tunnels, bridges, overpasses, trees, and long range, so that you can get through that system and you can get through it safely, move through the traffic. And that's really where the benefit of this new technology comes from, is it can overcome the obstacles of the past.
So Chief, we had an opportunity just recently to work with the Hillsborough County Fire Rescue Team, doing some training and showing them how to utilize Glance. One of the tools that we have as a part of the Glance system is really kind of a revolutionary way of showing what's going on a preemption run for the vehicle and the intersections after it's already happened. So we talked a lot about, we generate a bunch of data. What are we going to do with it? Well, this is a unique way of being able to share what happened with a run for a vehicle at intersections, time of day, duration, travel, all that kind of business. So on the screen you see one of the runs that we actually got to share with the Hillsborough County Fire Rescue folks that I thought showed how we make a difference in a picture. Our leadership is always big on, hey, I can show you a bunch of data, but show me what it means. Give me some context to it. What's the picture tell us that it's doing? As a kid, when I built models, I never read the instructions. I just looked at the images and tried to build it that way. And when I see information on a screen like this, it's much the same way. I can look at it and intuitively go, oh, wow, that's neat, because I get to see the trail. I get to see the intersections. I get to see some immediate feedback by colors, and it tells a story just by looking at it. So that's what this is about. So on the screen, I have actually moved the vehicle forward. I'll scrub it back to the very beginning, where I selected this particular vehicle. It's engine 5, and it had a listing of runs that go back through December. You see a pile of numbers that show that that's the runs that they generated during the month. As I open up the window, it's also showing a number of runs by time and date, the duration, and the length and time of each of the runs. And oftentimes I'll just go through and just scrub through and just click some and pull them up. In this particular case, March 17th, there was a run that happened at 2102 to 2111. And this fire truck, engine 5, was in a residential neighborhood. And so as they're kind of running through, you can see the gray line was their trail, and each of the dots that are on the map reflect the number of intersections that are there, or the intersections that are actually deployed. The larger dots that have the sage green on them at the beginning of the run indicate, hey, this is the trail, and these are the intersections that responded to the preemption request. And along the bottom here, we have a timeline where they began their run and they ended their run. And it's kind of a neat feature to be able to kind of click down here and speed up the vehicle. And I've clicked the go button, and you see the vehicle takes off, and there's a little speed bubble, and it's leaving an orange trail as it goes through the system. So to me, what we're seeing is the vehicle get up to speed on this major east-west arterial. It's like Fletcher Avenue. And you can see along the bottom, the speed is building up to the low 50s or so. So you can see there's a lot of distance being covered over time because they're able to maintain speed going through those intersections. But what to me is the part that denotes the most interesting part. I'll hit pause here. This is about a 9-minute run that shows by the start and the end. These guys, by this trail where I stopped, they've gone about 90% of the distance to travel, and they were able to do that at pace, at speed. And now they're going to pull off and go into this residential neighborhood that looks like a couple hundred yards. Might be a little bit more, but not too much. But you can see dramatically on this right-hand side, and I'll go ahead and hit the play, how much slower their pace of speed is once they get off the controlled intersections where the technology helps them advance through those intersections. Can you talk a little bit about maybe the value of improving the speeds and getting the speed where you can?
And that is what this picture shows you. This shows you the improvement in response time right there on the screen. It also shows you the safety factor has gone up dramatically because they're able to move through those intersections. Why is that apparatus operator able to clear signalized intersections on a big street that fast? Well, they can do it because they're looking out the windshield of the fire truck. They see the traffic flushed out of their way. They see the opposing approaches safely stopped, and they're able to move at pace right through those intersections, knowing that they're going to look, the time's going to get long at the end of the run. It also is a perfect picture of, as we talked about earlier, no hard braking, no evasive driving as far as turning goes. That is any fleet manager would look at that with a big smile on their face because they would see the brakes not being used. They would see the fire truck not having to decelerate and accelerate at a high pace. And so that's all wear and tear. They can see that improvement. So to me, the speed profile is the perfect picture of the improvement in your delivery of emergency services. And as a fire chief, you're always trying to find a way to tell the story to your elected officials because they're citizens. They don't necessarily understand everything about what you do. So in order to get budgets approved, in order to help yourself as far as your service delivery, you have to tell them the story. You have to show them what you're doing and how you're improving and how you're delivering to the citizens. I think this is also a picture of community risk reduction. That has been a big thing in the fire service, and it should be in every emergency service, is reducing the risk to the public. Many times in the fire chief's office, you think, well, community risk reductions, that's smoke alarm programs or sprinklers or codes or that sort of thing. This is one of the biggest features you can add to your system for community risk reduction because you respond to emergencies every day. You respond through hundreds of vehicles that are citizens that you are potentially impacting. Every one of those green dots on that map is a non-impact, a non-negative impact on the citizens. Smoke alarms are terribly valuable for public safety. They are very effective. We know in the fire service they've reduced fire deaths across this country dramatically, but you're impacting your traffic and the citizens hundreds of times. And so we owe it to the public, in my viewpoint, to put in these sorts of systems. We owe them that because we can reduce that potential negative impact as we respond through our communities.
I look at this trail and this vehicle as they were westbound on Fletcher Avenue. They peeled off to the right and went north. And there's a signal that's well beyond where they turned off, but it went green. And a lot of people will look at that and go, well, why did it do that? They turned off of that. That goes back to the ETA. They were at pace. They were traveling at 50 miles an hour, and they were within that 30-second ETA of those intersections. And it was preparing to clear out any queue of traffic that might be there. So it worked.
It worked very well. And I'd like to point out that as they're coming to that, we have to think about the fact that that light turned green to flush the traffic out of the way so they could get to the intersection to turn right. So many times that's one of the benefits of Glance is you can use the system design to help you get out of non-signalized intersections. In fact, there's a great test case in one of our jurisdictions where they have a stop sign not far out of the fire station on a route that they routinely run. Well, we used glance to stop the traffic upstream of that stop sign, so that as they come out of the fire station running emergency, they get to the stop sign. Now when they get to the stop sign and they bring the apparatus to a stop or near stop, they look to their left, they have an empty street because glance has held that traffic for them. They're able to move into a one-way street that's multiple lanes, and then they have green lights to their right in front of them. So it's made a huge difference in the safety of the response because we're holding that traffic, much like this is flushing the traffic upstream. So, you know, we're holding that traffic, yes, for a second, but it's a very short period of time, because as soon as that fire truck gets clear of that intersection, probably maybe as little as 30 feet, the system takes back over and goes back to its normal operation. So from a traffic engineer standpoint, you're actually maximizing the throughput of your traffic because you're controlling the chaos and you're getting that apparatus, that emergency vehicle, through the system. You're getting them on their way in the most efficient and effective way from a traffic perspective.
You've no doubt had conversations with administrators at fire services, whether they're city, county, state, all of them, and there's private agencies as well. What's the big piece of advice that you might have for an agency, somebody at administration who's looking at evaluating the idea of making an investment in a preemption system? How would you advise them to look at the technologies? There's a number out there, and offer them some fair advice about, hey, here's the real elements that you should be looking at, that based on your experience. How do you guide someone who's looking to take the leap in investing in a preemption system?
Well, and I think that's a great point, and everybody should look for a lot of the things we have already talked about. You're looking for a redundant communication system. You're looking for something that is going to work, and you know it's going to work because it has multiple ways of communicating. Something that gives you data back, something that actually tells you the performance of the system, something that you can look at hard facts on. This is how far we've gone. This is how we were able to accomplish our mission. This is the speed we were able to go. These are the routes. Something that gives you that picture, that quality assurance that the system is working and that it's performing and it's allowing you to perform in the way that you would want. You're also looking for that customer service standpoint. I mean, the simple fact is, who am I dealing with? Am I dealing with somebody that I can pick up the phone and get customer service? Because let's face it, everybody is going to have needs. And do you have questions? Do you have things that you don't understand about the system? So all of those things play into what I think we do best, and that is high quality communication and a system that we can show performs and show what you're accomplishing as you put that technology out there.
I'm going to go back in history a little bit for today, and we were watching that video, the fire truck's in the middle of the congestion. As a driver, what one word comes to your mind?
One word, I have to think about that a little bit. It's, unfortunately, sometimes you're thinking about, did nobody teach you how to drive? Yeah. And that is the thing, because people forget, or they panic and they do something that's unexpected. In fact, I saw a case just myself the other day recently, just on a personal trip, and I passed an ambulance going the other direction on a divided highway, and I saw the ambulance come past me, and the car in front of them, driving in the left lane, nobody in the right lane, just stopped. At highway, it was a state highway, 55 mile an hour speed limit, and they just stopped. And that poor ambulance driver did yeoman's work. I mean, they went all over the road and off the road and everywhere else, wow. But he didn't crash, and he was able to gain control of that thing. The driver just panicked. And that's what you worry about. You worry about them doing, you have to expect the unexpected.
So again, now as an administrator, as a chief, what's the one word that you would use to characterize what you saw?
I mean, it's just unacceptable. It's community risk reduction. It is liability. I mean, you're asking these apparatus operators to get the crew there to do their job. And you know you're asking them to do something because the public's at risk. Somebody has called on their worst day, and then you have traffic like that that's basically keeping them from doing their job. And it creates too much risk, an unacceptable, in my mind, level of risk for the public and for public safety professionals.
Chief, thanks so much for your time today. We've had an opportunity to talk about Glance. We had a chance to talk about some of our history in this industry, and certainly your experience as a driver and as an administrator. So a really valuable input. Thank you so much for sharing your experiences and your thoughts. Everyone, thanks for joining us today. We're super excited that you took the time to join us. If you get a chance, we'd love for you to like and subscribe to our channel if you haven't already. So again, from the iATL, thanks again. We're signing off today.
All right. Thank you so much, everyone. And we do have a couple questions for Jeff and Jackie. First question from Tom. Does the system know when a fire apparatus is going to make a turn at an upcoming intersection to clear the turn lane?
It actually does, and that's the reason that we connect to the turn signals. It actually puts your fire apparatus operator in control of their path, and it lets them go in the best way they need. Sometimes, road closures and that sort of thing. So just having a wave of green doesn't work. You need to put that apparatus operator in the driver's seat, for lack of a better word. And so it's connected to the turn signals, and they can use it to manage their route. Thanks for the question.
Yeah, I think in addition to that, the whole system operates on an ETA, the estimated time of arrival, at each of the equipped intersections. So they're all simultaneously seeing a vehicle coming in that direction. So it's already beginning a timing sequence based on the real time of the vehicle at that time. So some added information, as Chief Gibbs talked about, is looking at left and right turn signals and conditioning some rules and some zones on those approaches to say, yep, I see it. Now I'm going to advance, make sure that we get some special treatment at those intersections, again, based on monitoring either the left or the right turn signal. So it's a unique feature that makes that so much more special.
Perfect. Thank you for that. Now we have a question from William. William says, is it correct that if the street that they are turning onto has glance signal lights on it and the unit puts its turn signal on to turn onto that street, glance will start clearing the lights ahead of the route on the new street based on the turn signal being on?
That's correct. As we just said, it is connected to those turn signals. And as Jeff pointed out, you're also using the ETA to the signal. So it's doing all of those things. It knows you're coming, looking for you, and starting to flush that traffic out of the way as you make your turn. Thank you, William.
Perfect. Now we have James has a question. Do the benefits of glance allow for the chance of fire apparatus to drive silent without the siren and horns?
It does have that. That is a capability that is determined by the local jurisdictions. So you can use a run silent type of situation. Of course, that comes with it recommendations on policy and control, but it is available.
Yeah, I would say there's a growing trend in our industry to address that, not only from the fire and ambulance response, but also for the growing number of police users. Obviously, there are certain responses where they don't want to make a lot of noise. Similarly, on the ambulance, when they're taking patients back to the hospital facilities, oftentimes they don't want to cause more panic. So utilizing a tool like a silent run is a perfect way to do a preemption response without the noise, if you will. And I think one of the unique features within our system is that we can track them differently. So we know when it's on full lights and sirens, it leaves an orange trail, leaves a different color trail when they're doing silent. So there's some accountability that is designed into this system that again adds to the uniqueness and the features and the operations of this system.
Very nice. Okay, so oh, perfect. Another question from Stephen. Does Glance work with all traffic light manufacturers? Can you comment on the physical connection and logical interface?
Yeah, I think I'll take this one. I would say all modern traffic signal controllers is compatible with the system, even going back 20 years in technology. The physical connection between our devices and the traffic signal controllers really is two options. The conventional way is a logic ground input to the controller. It's like turning a light switch on for northbound preemption. We provide that. That's been around for 50 or 60 years. That sort of style of asking the controller to go into preemption. We also have an Ethernet connection that's from our device into the controller where we can request those devices to go into preemption through some communications as opposed to the conventional logic ground input. So our device is baked in with both options. So it just kind of depends on what the agency wants to do on triggering the preemptions, old school way with the logic ground input or the communication request through the Ethernet connection. Good question.
Thank you, Jeff. And there's another question that came in during the webinar. What are your #1 tips for a traffic engineer when it comes to deciding on what type of preemption system will work best for their city?
Ooh, that's a great question. We've talked about a number of the features just in the little Q&A session. What I hear from traffic engineers and traffic managers is looking for the return on the investment. So does it work? Does it serve itself as a preemption system? Do I have enough range? Does it give me enough information? Do I have enough security? Can I work with mutual aid agreements with agencies that might be around me or in my county? Does it give me some communication? As some agencies are looking at doing connected vehicle technology. So when they pull up to some of their intersections, that those devices have an ability to share connected vehicle elements with drivers there. So some other things that agencies are looking at, also connected with or associated with the connected vehicle side of the fence, is when emergency vehicles are on the side of the road rendering aid, is there some connected vehicle messages that the system offers that provides an added measure of safety. So those are really common elements that I think traffic engineers from the heart of the foundation, does it work and does it work well and reliably, to some of the other added benefits on the connected vehicle side. Chief, I might toss it to you about maybe some of your interactions with your department and talking with some of the traffic engineers you visited with.
For one of the things for us was we developed a very strong partnership with our traffic department that had not existed before, and that just was a game changer in the city, because your cities and counties are continuously growing, and so the fire department really needs to be connected to the traffic department and the modernization of the traffic system, because let's face it, we all have to use it. We're trying to get to emergencies, and we want to do that safely with the public. So very strong partnership came out of that, and we have a monthly meeting with our traffic department to stay on top of changes. And so it's really important. Also, as Jeff, I want to sort of emphasize, being able to communicate when you're on a scene is really important for the move over law and those sorts of things, because struck by for emergency responders is a serious issue and an important safety feature to get the public slowed down and moved over when you're working an emergency scene in the roadway. Thank you.
Yeah, I think additionally, going back to the heart of communication, every traffic engineer, everybody who's managing devices in the field wants to have remote access. So part of the feature set that our device has baked in is cellular communication. So if agencies are looking at getting access to the traffic signal cabinet, what a perfect solution. This device is there as a cellular modem. It's got a 4-port switch on the back that allows the agency to directly access their controller, or conflict monitor, MMU, video, any of the devices that are Ethernet based in those traffic signal cabinets now as a communications tool. set aside the preemption, again, the coolest on the planet, but it's a communication tool that these agencies get directly into their devices and are able to manage, upload, download, get directly into controllers. All the modern controllers, we have an interface that's a remote front panel access if you want to have it enabled. So any of the technical folks from engineering to traffic technicians, even in some cases, we have private contractors that are working on behalf of agencies that help to maintain and operate the traffic signal controllers. It's a fantastic way for them to be able to manage access to the traffic signal controllers and preemption and connected vehicles. So there's really a whole host of stacked reasons why traffic engineers are looking at this as a solution for preemption, and then all the other things it brings to the return on consideration for investment.
Thank you. Okay, we have a question from Ray. Are there future plans to integrate GLANCE into vehicles for vehicle to infrastructure and vehicle to vehicle communication?
It's done today. That's what we're doing now. One of the elements that we really haven't talked too much about is the Travel Safely app. So that's an app that comes through the GLANCE system. It's an Android or a iOS application. So that's what allows us to share connected vehicle messages, not only within proximity of fire trucks or intersections or other devices that we have. We have management in school zones as well. So there's some critical life-saving information that we can share through the Travel Safely app that gives us the vehicle to infrastructure application. There's sort of a vehicle to vehicle as well, where it looks at two Travel Safely apps, two different vehicles, proximity warnings that can be shared as well. We have a designation of either a motorist, a pedestrian, or a cyclist. So we have that little trifecta of, if it looks like a motorist is going to run into someone who's been designated as a cyclist or a pedestrian, there's audible alerts that both sides get from the system. So we definitely have some tools that let us play in sharing those critical safety messages. We're also partnering with companies like Waze, House Alerts, and a few others that we get to grow that message set in sharing information across different platforms. And again, all in the interest of helping agencies achieve some of their Vision Zero pursuits and reducing accidents and fatalities on the roadway. Great question.
All right, so we only have a couple minutes left and we have 3 more questions. We'll go over those, but if anyone needs to hop off, you can go ahead and do so, and I'll enter in our chat an email address that you can reach out to if you have any other questions. Okay, so next question is from Brian. How does GLANCE account for the queue that might exist even if the light is green for the emergency vehicle by the time it approaches the intersection?
Yeah, the thing that strikes me immediately is what plays into this is the ETA and the range. If they're starting right at an intersection, it just takes a little bit of time for the intersection to provide the light and people to navigate away. The idea that you saw in the Hillsborough County video towards the end of our broadcast, when vehicles are out on the roadway and using that estimated time of arrival, that queue time really diminishes pretty quickly. So it has a really nice way of being able to manage that clearance before the vehicles ever get there. I think one other added benefit that's a part of that, because of the range, a lot of traffic engineers look at that and think, man, you're going to preempt my intersections a lot longer in time and duration because you're communicating so much further away. And the opposite is really true. What we're seeing is there's a 15 to 20% reduction in overall preemption time because of the range, the vehicle's moving and staying at speed, the queues of traffic that might be stuck before now get a green light before the vehicle gets there. So they're able to cruise through the intersection at normal response speed, terminate the call as they pass through the middle of the intersection, and actually reduce the impact of preemption on average runs by a pretty significant amount because of the way that we have extra range and address the way that the ETA operates at the intersection. Chief, I don't know if you had any other additional comments on it.
No, I think that's spot on. I mean, I think you see that improvement all the way around. So thanks.
Cool, thanks.
Okay. Now we have a question from Michael. Despite the importance of responding to emergencies in a timely manner, members of the general public and even traffic signals engineers may be bothered by the disruptions caused by preemption. How have you measured impacts to general traffic, side street traffic in particular?
I think the big thing for us is we know that just by nature of the word preemption, that we're changing the cycle times, that we're changing the assigned or detection times at the intersection. So it really is a measure and a management of trade-off in meeting some goals for the city and safety and emergency response and response times, balancing that out from changing what the most traffic agencies spend a lot of time and money in managing coordination. Some cities around the country, that's all we focus on, and certainly understand that. But there's a decision that agencies have to kind of make about this balance of, if I pick the right system and have the right approvals, and a technology helps me to achieve the emergency response with a minimal impact to my intersections, that's the one I want. And part of that is having a tool that allows the agencies to look at that and see what the real impacts are. And we didn't really get into the deep detailed numbers on what we're doing with Glance, but we know at the very beginning how long, how far away, the total duration, changes of intervals at the intersections. So we get to see at a very meticulous level of what happens at an intersection. And it's an important part of how agencies on the traffic engineering side get to look at the data and make a decision on what technology would be best in the event that they're willing to go ahead and move in the area of allowing emergency vehicles to have preemption at intersections. I hope that answered the question that was asked. That's the way it hit me.
Yeah, and I'd like to add to that, Jeff. Traffic coordination, signal coordination is a wonderful thing, but you have to keep in mind that emergency is going to occur, and that fire apparatus is coming through the system, and they're coming through the system in the most disruptive way without any sort of preemption. So the traffic is not going to be in sync with the signals. So you've lost that coordination off the bat. That's already off the table in my mind. And so creating a non-chaotic response is going to be, and it's going to prove itself quickly to be not only safer, but you're going to have a better throughput on your traffic, because the traffic will stay in coordination, not just the system. Traffic signals are great, but if that traffic is having to stop and get out of the way and all that sort of thing, you've lost control of that anyway. So thank you. Great question.
All right, well, we've reached the end of our time together today. Thank you, Jackie. Thank you, Jeff, so much, and everyone who attended. I know there were a couple of questions left, so we will reach out to you individually after today. Thank you so much, and we'll see you next time.